Alright, let's start here. A few things, just some reminders first of all. Composite and inverse functions. So, composite function. That's the fog and Goff and stuff. So Goff is a composite function, composition of f followed by g. Alright, for example, so Goff of x simply means that for g of x, you put f of x in there. So it's composition of two functions. Now, it's not always defined. The numbers you get for f, you have to actually be able to put into the g function. So, Goff is defined if the range of g, the range of f is a subset or equal to the domain of g. So say for example, if g of x, for example, is square root x, then f, you've got to be able to put f in there and be able to, so if f gives you a negative answer, you can't put that in there. So that's why the range of f, the numbers you get out of f, you've got to be able to put in here. If you can't put them in there, then Goff doesn't exist. The other thing is that the domain of Goff is equal to the domain of f. Alright, so that's where you start. You start with the domain of f, you put it into f, you then put that into g, and then you get your answer. So an example might be something like this. Alright, so it says express hx equals e to the x squared as a composite function. So when you look at this, we've got two things going on. We've got e to the power of something going on, and the power of something is also the function. It's an x squared. So if that was if fx was x squared, then you'd stick that in the e to the power of, and then have your, so if we have f of x is equal to x squared, and g of x is equal to e to the x, then h of x would be g of f of x Alright, so if you like, g, excuse me, so we're doing e to the f of x, yep, and f of x is of course x squared. So that's GOF. So that's our composites, remind you about that. So we're taking one function and we're putting it inside another one. Alright, so the two functions we had here was x squared and e to the x, and we put the x squared in there. Alright, so now I rub that off.
Everything but the example.
Everything but the example. Alright. Alright, just remind you now
Not
about
getting late, and you still haven't written everything you want.
I'm sorry.
the inverse function. So remember f minus 1 of x represents the inverse function. Alright, so if we want to find an inverse function, there's a couple of things we can do. What are they?
Swap one.
Swap the y and the x, yep. Oops, can't spell it. Alright, so that's one way we can do it. The other way is, if we've got a graph, we could
Do you know?
To draw the diagonal line and then
draw the diagonal line, yep. And that diagonal line would be,
Y equals X.
very good, so to reflect in y equals x. Alright, oops, y equals 2, y equals x. Okay, there's been exam questions that have asked for both, not necessarily both at the same time, but both of those. All right, so an example. All right, simple one, fx equals 1 on root x for x is an element of r plus. All right, so it's got to be r plus. If we had negative numbers in there, we couldn't get real solutions, so it's r plus. Can't be 0 either, because the square root of 0 is 0, and then we've got something undefined. All right. So if we start with y equals 1 on root x, and then using that first one, we're swapping those, then rearranging. Oops. So we swap, now we rearrange, get rid of the square root, square both sides. Times both sides by y and divide by x squared, you get that. So, it's also important that on the exam, if you leave it like that, you won't get all the marks.
You have to do the F take one.
You have to write your final answer, all right, in the same notation that the question was asked. So the question was asked in function notation. We've got to give our answer in function notation as well. All right, and x is still an element of r plus. Alright, a couple of definitions of things that we haven't seen before. And that is strictly increasing and decreasing. Strictly increasing, all that means is it's getting bigger. I'll write the mathematical stuff. So a function strictly increasing. If A is greater than B, f of A greater than f of B for all A and B. As long as there, of course, an element of the domain of f. Alright, that's the mathematical mumbo jumbo. What does that mean? What it means is that something's strictly increasing if the gradient is positive. Alright, now there's a couple of things about that. If f is strictly increasing, then it's a one-to-one function. Alright, so one x value gives you one y value. And if f is strictly increasing, so is its inverse. So just some graphs here. So, for example, a graph that might be like this, for example, cubic kind of graph would be strictly increasing. Alright. So for some x value that's bigger than this x value, some x value over here bigger than this one, we want the y to be bigger than this y. Right, that's what all that's saying, so positive gradient. So that would be strictly increasing. Whereas something like this, for example, would not be strictly increasing, because any x value bigger than this one, so I might choose this x value, so that's my A, and I might choose this x value down here as my B, so A is bigger than B, but when I come up to there and look at the y values, strictly increasing says that this y value has to be bigger than that one, which is clearly not. So this is not an increasing function. All right. And then, of course, there's strictly decreasing, which is all the opposite to that.
Mr. Simon,
Yes.
doesn't that mean that it could just be both?
Well,
Move
part of it is, yeah. So with this parabola up to this point there, it's decreasing, isn't it? And then after that, it's increasing. So if we restricted the domain on that, then yes, we could have.
Is there a restriction on where you can place A and B or not?
You can place A and B wherever you like, and A is bigger than B, and always when you put A in, the answer you get out, the Y value, has got to be bigger than when you put B in, always. So if there's, as in this, clearly this Y value is bigger than that one, so it doesn't fit the definition.
Yeah, but I mean, could you put A where B is and B where A is?
No, because A has to be bigger than B.
Okay.
All right. Anything else? No. All right. I'm going to be lazy.
Wow.
Oh. Yay.
Lucky person who gets to watch this.
All right. So for strictly decreasing,
You forgot like two other increasing.
strictly decreasing, that's got to be less than.
So does the other one have the A?
No, A is still bigger than B. That's right. Yep. Got this one and this one. You could probably just like right above it in red or something, different colour.
Hang on, so the sign.
One sign swaps around.
Only one of them.
Yeah, this sign swaps.
But the other sign stays.
That one stays. So the A is still down that end in the X and the B this way.
Yeah.
So now the Y value is smaller than this one. So strictly decreasing. Let's go.
So they're both one to one.
1 to 1, yes. So here's a strictly decreasing one. So A's got to be here somewhere. B can be anywhere you like as long as it's... And then we're comparing Y values. So this Y value's got to be less than this one, which it is. So that one's strictly decreasing. And we get a parabola or something like that. would not necessarily be. Now, as discussed before, when you may get a function where you restrict the domain of that function, because it says here a and b are an element of the domain of the function. So if we restricted a function, so domain, so for example, if we're going y equals negative x squared, where x is an element of R positive, so now we've restricted our domain. So that would be this half of the upside down parabola. And so now A and B have to be in here. Can't have A or B down here because that's not part of the domain of this function. So this could be A there, that could be B there. And so that's strictly decreasing. Right. But if we didn't have that restriction and we had this other side as well, then it wouldn't be.
So hang on, that one's.
This one here, with this restriction, is strictly decreasing. If we didn't have a restriction on what x could be, it would not be, because we would then get this. Alright, and if you think about the gradient, it's negative. So from there, for that parabola, the gradient is negative, but if we have this bit, it's positive on that side. Right.
What if the A, like in that case, is further than the asymptote? Does that mean it's just not valid?
Oh, you would need to look at the question and have a look. It's probably going to give restrictions to take into account of that sort of stuff, I would think. Right. Sums and products. Let's have a look at sums and products. This is the last thing today, sums and products. Alright, so again, this is a reminder, f plus g of x, oops. What that means is that you take f of x and g of x, add them together, and the domain of f plus g is the intersection between the individual domains. Alright, so I have one that looks like that, and I have another one that looks like like that, then I can only add these two things together where I've got two lots to add together. So if I haven't got this bit here, I've got nothing to add together, so f plus g will only be the intersection between those domains. Right, so f plus g domain would be here. I think, remember, is the product. Product is FG. And this means we might take f of x and g of x and we multiply them together. And again, the same with the domain of fg, you've got to have things to multiply together. So again here, got nothing, no green to multiply over here with the blue. Over here, sure, we've got things we can multiply together. Right, example. Alright, so here we've got a couple of functions, cos x and e to the negative x. So both of these, the domains are all real numbers. Just cos x, just a rough sketch. Cos x wiggles like this, both ways, far as you like. E to the negative x goes like this. So there's no restriction on what x can be. So all is good. So all we need to do is just, for this one, f plus g, is just add these together. So f plus g, put it in blue so it stands out. So simply just cos x plus e to the minus x. Simple as that. And fg of x is when we just multiply these two things together. Do it in green to make it stand out. So, just multiply them together. Just because f is cos doesn't mean that the cos needs to be in front. We can multiply in any order. Looks nicer that way. Alright, so f plus g of 0, it just means you put 0 in here for x. And so f plus g of 0 would be cos of 0 plus e to the 0. Cos of 0 is e to the 0 is, so that's 2. And f times g
0.
of 0 is e to the 0 times cos of 0, which is 1 times 1, which is
1.
no, right. Righto. That's it. All today. So that's two exercises today. 7B and C.